Hello. Have you watched the recent uh, Avengers Endgame movie and wondered what would happen after this? Will there be a movie that Marvel will make even after Iron Man is no more? Well, you know the answer. They have made a movie and they actually have planned of making other movies. So it's not really the end, even though we think it has ended. Why is it that I'm talking all about that? It's because today's discussion is also about a topic which really is never ending. It's our discussion on graphs once more. Now, graphs are a wonderful way of summarizing informations, and truly we can learn a lot about whether we have learned the things properly or not. So let's see what we can learn from today's discussion on graphs. Now, today also I'll be taking some questions from previous IB question papers. However, this is also equally relevant for all students who are pursuing physics in high school level. So let's begin with our discussion on graphs with these questions brought by Upthrust. Okay, now this is the first question. As you can see, if you can have a look, you may want to pause the video and have a look at this question. Now, of course, for answering this, you have to be aware of how the relation between potential and electric field is for point charges. But more importantly, you have to understand which part of the graph is it that we can use to get answer to this question. So if you look into this, at the point x equals 0.8, you can see that the potential is minimum. Obviously, that means that the slope of the graph at that point is 0. So how can you use this information to good effect? Now, if you think of it, the gradient of a potential versus distance graph, which is delta V upon delta X, is actually nothing but electric field. So what the graph is suggesting very, very subtly is that the electric field at that point, the resultant electric field is 0. Now, how can we get the electric field due to these 2 point charges? We know that we have the expression of electric field that is available to us. So let's see whether we can make use of it. Now, this is obviously the realization that we have got, and let's go to the electric field expression. Now, since it's 0, that means the electric field due to the 2 separate charges are balancing each other out, which is why I've written that they are equal. And you can understand that since the distance of separation is 1 meter, so if it's 0.8 from one of the charges, it has to be 0.2 from the other. So this is the expression that we get. And after that, I think it's quite easy to get along. We just have to simplify this, and we have got the ratio of these 2 charges. And finally, if you simplify it more, this is what you get, and you get your answer. So the key point that has to be taken from this question is that although in the beginning it seemed like how is it that I'm going to find out the ratio of Q1 and Q2, but over here actually the knowledge of how to extract information from the graph, trying to focus on what the slope tells you, and in certain cases, in certain questions, you have to understand what the area of the graph gives you. Mostly these 2 things will give you something interesting that has to do with solving the questions. So MCQ questions, I feel particularly for IB is one of the toughest, because even though you look at the mark scheme, you do not get the way to solve it. You only get the answer, but how to arrive at the answer? It is for this reason that we have these discussions. So I hope this was fine with all of you. Let's move on to another question. So this one is a question on simple harmonic motion. And you can see that we have to predict how kinetic energy is varying with time. Now we know that for simple harmonic motion, the displacement time graph is either a sine or a cosine curve, which means the velocity, if you have learned it before, the velocity is also something like that. However, if displacement time is sine, velocity time is cosine, and vice versa. So the reason I'm letting you know about that is because kinetic energy is the square of velocity. Now you know that if velocity is sine or cosine, uh, the kinetic energy would be square of that. So you'll have to know a bit about how does the sine square or the cosine square function look like. You can also find it out by just doing it mentally. You know that sine of any function varies between +1 and -1. So if you square it, you can understand it will vary from 0 to +1. It cannot be negative, which means we immediately rule out the first two options, A and B, because over there the kinetic energy or the velocity square function is shown to be having both positive and negative values, which is impossible. So we have to deal with option C or D, but which one between the two? Now, again, if you think of it and look into the question carefully, here it is that these questions are so very important to be read properly, to be understood properly. It says that the particle has been displaced from rest. So it's best to imagine SHM, in my opinion, with the help of pendulum. So if you have it, you displace it from the equilibrium position to its extreme position, from where you let go. So obviously the pendulum will start oscillating, but key point to be kept in mind is that at time t equals to 0, when you made it oscillate, the velocity was 0, which means so was the kinetic energy. And there you can understand that it's only option D that you can have, because option C you have at time t equals to 0, the kinetic energy is not 0. So by doing it this way, you can definitely understand that it's going to be option D. But what if someone wanted a more detailed mathematical analysis? I know that some of you would like to do that. So for all those interesting ways of doing it, or for all those who are interested in doing it that way, let's try to do it in this way. If you have the position to be something like this, and that's because it's being made to oscillate after being displaced from its equilibrium position. So that means it's a cosine function. The displacement time graph is looking like that. So obviously the velocity will look something like this. This has got to do with a bit of application of calculus over here. So if you are okay with that, you can do it by differentiation. So kinetic energy, which is varying as V square, would be actually varying with sine square of omega t, and which can be written as something like this. Now you can look into this as omega t is 0, you can see that the kinetic energy is 0 as well, because cos of 2 omega t, that will be 1, and 1 minus 1, this part will give you 0. So obviously it's going to be answer D or option D. So this is a short discussion on two questions of IB physics, but I hope you understand. I'm sure they're equally applicable to all students who are pursuing physics in the high school level. But what is important to understand is to number one, look into the question very carefully, and then of course trying to understand how is it that the information given in the graph can be applied to solve the question. So that's definitely an important part of understanding the way of going through the graphs. So I think that really the discussion on graphs and the discussion on physics in general in high school level, whether it's IB or A levels or whatever boards that you are doing it from, that really is a never-ending journey, because there are so many variety of questions to go through and so many interesting things to understand and discover and rediscover, that if you're really interested about it, or if you have someone who knows how to make it interesting, then you can really have a great time going through it. And I hope you all are having that. In case if you need any help with respect to physics in either of these two boards or in any other board, you can let me know. My email is given in the description box. And till then, it's goodbye from my end. Have a great day. Take care and bye bye.